Hi everyone, and welcome to the final lecture in this lecture series on research methods for the social sciences. Today we're going to talk about something interesting, big data. So the plan today, we'll just talk about big data. That's all there is to it. So why are we studying this? You may wonder, because the phrase big data might seem like something that you've heard about in the news media, and you might associate really with kind of a whole class of kind of controversies over artificial intelligence. And this might seem to be somewhat removed from the concerns of social science, but this actually turns out to be quite closely related. So let me say this right here. How does the use of big data relate to what we've already discussed? Analysis of big data, generally speaking, involves some kind of content analysis, which you can think about as a broad umbrella term that basically relates to the use of some kind of basic statistical techniques on words. So we don't here just mean words like the number 10 or something like that, but just kind of natural language content. So things that people wrote for purposes of human communication and not things that they wrote, for example, for the sake of recording survey data, which is what I'm saying here. This is applied to text that a researcher did not necessarily gather herself, and neither did anyone else. So here's the kind of classic case that I'll give you that's distinct from social research. In social research, we might analyze, say, words in the minimal sense that someone writes down the number 12 for the number of years of education on a survey, and then we turn that into a number proper, and then we calculate the mean over all observations on the variable education. What big data might look like would be something like this. We've got data that are, say, spam emails, and we want to build some kind of a spam filter. And it may or may not surprise you to learn that building a spam filter is essentially a task of writing a simple regression model of the type that we've already seen before. And in fact, a class of regression models known as logistic regression models, those that take a bunch of smooth or continuous inputs and predict a binary output, that's basically how a spam filter works. So spam filters are just one example. That's kind of an older machine learning technology or slightly artificial intelligence technology. But it turns out to be very closely related to what we did at the start of the semester, but applying those techniques to text that comes from the kind of quotidian social life rather than some kind of deliberate survey gathered for the purpose of producing information about society. So statistical analysis of big data then count as some form of mixed methods research, I would say. And another reason, apart from the kind of fact that this is a good example of mixed methods research, is what I mentioned before, that there is an important commercial application, which is machine learning. So that's why we're going to talk about this. So let's try to define big data. We'll make an effort at a definition here. There's a variety of ones that exist. Here's one. Big data are defined by the 3 V's. There's volume, variety, and velocity, and lots of them. So volume basically meaning the total. Again, if you think about your data matrix, which is a 2-dimensional surface, you can think about it almost as 3-dimensional. So one dimension is the number of observations, another dimension is the number of variables, and then a third dimension is the number of possible responses to each variable. Generally speaking, big data have larger n, k, and then values of x sub k, and then larger values of the possible variables or possible values of the variables than we're used to. Also, in terms of variety, this is a little bit hand wavy, but basically what we mean here is we might have data on things that you normally don't get through survey research. And then finally, velocity, right? So this basically means that the data are available roughly in real time. This is, obviously a bit of an informal definition, but I think it's kind of nice. This one comes from Forbes. Here's another one: organic data versus design data. So this is another way of thinking about it. It's organic data that are those that come basically incidentally. So they are gathered in the course of everything being online effectively. They're types of data that you could gather using offline sources or could gather in an offline fashion, but would be much harder. So for instance, information on, say, whether or not people are likely to buy a particular car after viewing an advertisement. This is something that's kind of interesting, but remarkably, the discipline of advertising itself, which has existed in its contemporary form for over 100 years, for a very long time, outside of focus groups, people couldn't really tell if, for instance, watching a particular ad would lead someone to have any further involvement in the process of buying the product. Whereas now, even if you turn off all kinds of web tracking and this sort of thing, think about when you're watching television and you see something about a choice of ads, for instance, and you click on a particular ad and then there's a link embedded in the ad, right? Or there's an ad embedded in your YouTube videos. And you can actually measure the conversion rate as it's known. So even if there's very minimal tracking, you kind of minimize your use of cookies. Generally speaking, people can still say, look at, okay, we had this ad run at this time, and then we had this flood of visits to our website. That's pretty remarkable stuff that just wouldn't have been very easy to analyze before the rise of the internet. So this is something to consider. That's actually not like super organic data in the sense that those are still designed by someone, but we'll talk about some of those nuances a little bit later on. As I mentioned before, you can also think about this in terms of the distinction between first-hand data and second-hand data that we developed before. So second-hand data are generally survey research data. First-hand data are generally qualitative data. This kind of has an interesting combination, though, where these are gathered firsthand. We directly observe people or we use their direct words. But at the same time, we have huge amounts of it. We don't have to personally interface with people in order to gather it. And so it kind of has this interesting character where on one level, it's like, according to my definition, technically qualitative data, but many of the other properties of the data set look like quantitative data. So it's actually really interesting. Again, this sort of controversy that might have seemed like a controversy in commercial developments in AI actually has some really interesting bearings on social science literature. More prosaically, this is Salganik's definition, the reading for today. He writes that big data are created and collected by companies and governments for purposes other than research and therefore require repurposing, which I think is a nice way to put it. But this still doesn't quite really get at it because there are all kinds of example data sets from the past where data might be gathered, say, for the purpose of surveillance or the purpose of trying to prevail in some kind of military conflict, but they become useful to researchers later on. Big data are still different further in that they are typically micro level and they involve a lot of times textual and kind of personal subjective data that we would typically only associate with qualitative data. So I want to first give you a bit of a sense of the scale of the data revolution. So advances in computing power have outstripped the growth of productivity in virtually any other industry. I'm going to pull up this graph here. This is known as Moore's Law, and Moore's Law says that although it's not a theoretical law, it's just kind of a generalization. It's based on an article in a computer magazine from the 1960s, but it's turned out to be true, that roughly every 18 months, computing power, which is measured basically by the number of transistors present on a computer chip, doubles. And you can see here that you've got this logarithmic scale, so these even increments are going up by powers. So when you see a linear relationship here, this means that there's a nonlinear or exponential relationship between the actual value of computing power and time. So that means that more and more stuff is on the internet. It's cheaper and cheaper to calculate stuff. It's cheaper and cheaper to store stuff all of the time. So just kind of useful background here. Source for this is a really nice book by Brynjolfsson and McAfee, which is an early and I think useful effort to think about problems in social life as they confront AI. And this is something that's really interesting, by the way, because relatively few researchers in the social sciences actually directly talk about these issues. And a lot of the people who do tend to be kind of celebrity academics who might have some kind of relationship to the commercial world. But traditional academics have been somewhat slow to address some of these issues. So it's another reason I want to address it with you. So how do we analyze big data? What's our means of analysis? You do have some strictly quantitative techniques. So you could look and see like if the frequency of tweeting is associated with a higher number of followers, just to pick something trivial but kind of interesting. You could also look at strictly qualitative techniques. So you could look at an ethnography of viral tweets or linguistic analyses of changes to a person's Twitter bio. But you can also use mixed methods techniques, and these are fairly common. So a typical use might be content analysis using computer methods to code. So things here, again, might be that you try to, for example, predict by, say, the length of words in an email or the presence of misspelled words or the presence of, a lot of times spam emails, for instance, are written in forms of English that are outdated, or forms of English that are kind of like, back in the bad old days, spam used to be very crude. I don't mean like that it was like scandalous or something, but or lascivious, but I mean that it was like oftentimes written very poorly because people would use some amount of really primitive AI, and it turns out that you can like find out when really atypical words are used. Kind of like if you use Google Translate. Even as recently as like 10 years ago, if you use Google Translate, a lot of times it would give really obscure words where more common ones might be better because the algorithm wasn't that good. So things like that. And that's a case where you're using text, but you're using text in a way that's somewhat statistical or is based on the statistical properties of the text. The exact kind of character of these data would be an interesting thing to think about, but here I just want to mention that the exact character is less important than the fact that this is kind of right on the border between quantitative and qualitative. So now in this part of the lecture, I want to basically just take you through a tour of what big data analysis looks like by walking carefully through 10 characteristics of the data, following Salganik. His text here is quite good. And looking at some original examples using some of my own research, but also some of the examples that he presents. I'll show you a little bit more detail using the original papers, and I think that'll be an interesting look at this type of analysis. So now let's take a look at those 10 characteristics. So these all come from Salganik. First of all, big data can literally be very big. What do we mean by this? Well, let's consider Google searches, for instance. We'll return to these later. There are about 5.6 billion a day, which is pretty remarkable. But when you consider how often you or I might Google things, and let's say conservatively maybe 1/3 to 1/2 of the world is kind of really logged into the grid in the sense that we all in the United States are, meaning that most of us walk around with what would have been 30 years ago supercomputers basically just in our phones. If you think about it then, that's really not that many searches a day per person. And then we have to consider that some people probably on their job, are Googling things all the time. I just spoke with a friend of mine, for instance, who very frequently as part of his job just has to send certain queries to Google. So there's a lot. There's a blessing of this, which is that we often elsewhere have the problem of small n's. Here we obviously don't. But there's also a curse. So the inference can sometimes be difficult to interpret. For instance, if we're thinking about calculating descriptive or analytical statistics, especially inferential statistics, like what does a confidence interval mean when you have the entire population of data? In a way, this is actually not such a bad problem to have because you just have the population. You don't really have to do inferential statistics. You can just calculate descriptive statistics. But at the same time, sometimes this also can be somewhat jarring because people will continue to calculate them anyways, and then there's quite a few interminable debates about, say, the universe of possible universes. There's a couple of really good books on what are called finite population statistics. The classic is by Leslie Kish, I think 1965. It's got some very generic name, but it's a really interesting text. But, for a long time, statistics really didn't deal very explicitly with the problem of finite populations. And if you've ever taken a kind of classical statistics class, you probably have spent some time on, for example, analogies involving the flipping of coins or the rolling of dice. And in these scenarios, you have what are known as infinite populations, meaning that the number of coin flips can't ever run out in some sense. Obviously, people might get tired and stop flipping them, but there's no conceptual problem. Whereas in this particular scenario, we're talking about potentially having access to every Google search done at some particular point in time. Now, no one actually would have that amount of data, that even for big data is just too big. But still, a lot of times you can have very large shares of the population. Another characteristic is that these are always on. So real-time data gives panel data with granularity that's oftentimes hard to obtain outside of time and motion studies. So we have data on what people are doing at a very micro scale that's constantly being collected. And again, this is very different to survey research. So here's a good example from Salgonic, some of these always-on big data sources. You can see here there's a variety of different scenarios where basically people were able to study events in ways that would have just been entirely impossible prior. So, for example, some of the, what's maybe the most familiar to someone. Actually, this is kind of interesting. People might not even know this, but even as far back as September 11th, we had a couple of examples of these kind of always-on data sources where things were processed in real time, not just the events themselves, but people's reactions to them in ways that just would have not been possible, say, 20 years prior. There's some phenomena like that, like call-in radio shows, for instance. There have been some studies along those lines. But just the sheer volume of data, not possible. So this is really new. It's, like I said before, pretty hard to imagine getting this level of specific time series information. So here's another example that I wanted to show. This is Google searches for depression at different times throughout the year. You can see that this is a way of very quickly getting a handle on a potential relationship between two variables that otherwise might be difficult, right? We talked about, for instance, the problem of using Likert scales. They're very unrealistic in very different ways, or in a number of different ways. Also, how often do we interview people, say, day in, day out for an entire year? That's really granular panel data. So what would the alternative to this be? It would be something like saying, okay, when, let's say you have a survey that interviews people and you catch a bunch of people in the summer, you would have to be asking questions such as, back about 3 or 4 months ago, it was very cold and dark. Do you remember feeling more depressed then? And this is the type of question that people are generally speaking going to find it difficult to answer with any real accuracy. So that's one benefit of big data. The other thing, or one other thing that I wanted to note here is that they're non-reactive in that way, and this is the point that I was sort of just making with respect to depression too. People Googling depression is a much more private act than people, say, confessing to a researcher whom they can see in front of them that they are in fact depressed. So there's fewer Hawthorne effects here in the case of big data. To the right, you can see this is a really interesting study. Some researchers regressed the change in the vote for the Democratic Party, in the House and President as a function of the racially charged search rate, basically searches that included explicit slurs or things like it. And this is a really interesting figure here. Now, the relationship is not super strong, admittedly. These lines of best fit obviously have a fairly large mean squared error. But you can see that there does appear to be something of a relationship here. And so this is the type of study that would just be entirely impossible to carry out, obviously, because one, for instance, people are really motivated in the United States, even if they are personally quite racist. There's a very large social penalty in the United States, which is a good thing, but in that sense, we are a markedly different society than we once were, and being openly racist is simply, in most cases, not tolerated. This is remarkable because you can tell people to respond to survey researchers, and even people whom we know, just from the area that they live in. 90% of people in this county, for instance, vote for openly xenophobic candidates. People in that region will all kind of swear that they are not personally racist. So there is a penalty on open racism in the United States, and for that reason, this type of study is a way of getting around that kind of explicit invocation of racist ideas. So here's another key characteristic that I wanted to mention. Big data are incomplete. So this is kind of turning to the sort of, from the pro list to the con list, The data that you can actually get your mitts on are unlikely to have all of the data that you want. And you oftentimes have to stretch available data to capture certain constructs. So for example, here, this is a nicely titled figure from Salganic. These are digital traces that were used to operationalize theoretical constructs. In plainer language, here's the data that people actually had, and then here's what they were saying it represented. So for example, people a lot of times, like this is a classic case, like to try to study social networks using Facebook because, hey, it's called The Social Network, right? The big famous movie is titled blah, blah, blah. Of course, there's a giant gap between an actual social network and a website that simply markets itself as one, which is a very pale imitation of an actual social network. There's a lot of really interesting research that Facebook itself actually does. Facebook, giant, extremely profitable firm. They employ a number of people that study this type of stuff. Actually, I'll mention something kind of interesting for the younger folks in the audience here. I actually knew a guy for a while who was the official sociologist of Snapchat, which I'm not sure that they actually needed such a person on board, but it was kind of a cool job. He was an interesting guy, is an interesting guy. But anyways, you always have to be careful. And this is a problem that happens in survey research as well, but it can be more pronounced in this case because the data aren't fit for purpose. Sorry about the out of order slide here, or the out of order animation. One point kind of, again, sort of in the con list, and also that might be somewhat surprising, is that sometimes big data are inaccessible. So this is just directly from Salganic. Many sources of big data that would be useful are controlled and restricted by governments or companies. So this can be somewhat surprising, but of course, there's been a bit of a backlash to the sort of omnipresence of the internet. Here, this is a really interesting kind of study here about some of the problems with the kind of head of research at AOL, basically. He tried to release anonymized search queries, and then he accidentally someone else showed that these could be linked to individual users. So there's all kinds of backlash, basically, to this and similar events. And for kind of a related reason, there's also been a huge emphasis now on privacy in ways that, really restrict the information that researchers can get, which is probably a good thing. One point on that is that for, one reason that there has been such a backlash is that, among other things, the very famous, although at this point kind of forgotten to history, but this is a big deal when I was in college, the NSA spying scandal. That was a really good example of how much people could figure out about other people with only metadata. In other words, they didn't really have information about what individuals were actually doing. They didn't have identifying information, but they had information, for instance, about who someone was calling, right? So they didn't know the content of the conversations, but they knew who people were contacting. And it turns out, we'll see a little bit later in the lecture, that there's a ton you can learn about people without actually having a lot of direct information. I think in one of my recent lectures, the ethics lecture, I mentioned a little bit about a doxing scandal in economics, where some economics researchers were doxing members of a site as part of a research project, or were at least threatening to do so on Twitter, which is probably not the best way to conduct these things, from an economics posting website that they thought was kind of sexist, and in fact it is. But there was kind of, again, this really interesting fact that they were able to geolocate people with relatively little information. The website administrator didn't do certain standard protocols that he wasn't legally required to do, but he just kind of made a couple of mistakes, and it turns out that that was enough to, without too much effort, basically figure out who individuals were. They had to do some keyword searches for geographic regions that the posters mention and stuff like that, or languages that they speak, but other than that, it was relatively easy. So another characteristic worth noting here is the non-representativeness of the data. This, of course, is potentially a pretty serious problem when you consider who actually uses the internet. So there are relatively few cases where big data are produced by a random subset of a population of interest, although this is possible. A little bit more on that later. One possibility is you can monitor changes in this subset over time, much like a bathroom scale that's initially wrong, but stays wrong in the same way. You can kind of correct for this bias as long as the bias is, generally speaking, monitorable. that's probably not a word, observable. Here you can see this really interesting case from Twitter. So this is Twitter. Some researchers basically tried to predict the share of votes that people would get, basically by the amount of Twitter mentions that they got. This is really quite interesting. Notice that this graph here happens to, this looks very good, right? But this graph actually omits mentions of the Pirate Party. This is Piraten here, because that's a party that kind of achieved a certain meme status on Twitter. So you kind of have to consider the fact that, like, yeah, this is an impressive figure overall, but we only get that by dropping a party that had an enormous number of Twitter mentions, and this is because people who use Twitter are obviously not a random subset of the population. They're people that are much more into what we might call internet humor than are other people, and so such a party is obviously, or was, much more popular. Again, that party's kind of faded in popularity since then. So here's an interesting example of attempting to measure a fairly abstract concept, the happiness of Twitter, produced by the people over at Hedonometer, which hedonics basically is the study of like the satisfaction that people get from goods and services, which is about the fakest science you can imagine, but there's something to it, but it's something you got to be careful about. Anyways, this is a kind of well-known figure in this sort of data science community. It's a really interesting attempt to do some kind of content analysis to study the happiness that people are feeling on different days. You can see this is over a long period of time here. But you got to consider, again, if this is not a representative subset of the population, we have to do some pretty serious post-stratification of the data to try to figure out, basically what can this actually tell us about the happiness of the underlying population at large. I guess that's redundant, population. So note that the researchers are using a form of content analysis, which we didn't end up having a lot of time to actually study, but it's pretty interesting here, right? So how are words assigned a happiness score? And the researchers had to do quite a bit of manual coding here, or they assigned it to other people that they were paying. So there's not really like a magic way around some of those problems, even with big data, just worth noting. Here is a kind of other example. This is some research that I did basically just for the sake of my own curiosity about the relationship or possibly lack thereof between changes in mobility during the COVID-19 pandemic and excess mortality. During the pandemic, Google and Apple made various kinds of mobility data freely available, and you can see those here. This is for a variety of different countries, different types of mobility. This graph is a little old. I probably should have remade it to make it look a little bit nicer. But you can see here, this is changes in excess mortality in 4 selected countries, the UK, the US, New Zealand, and Australia. And then this is changes in their transit usage. This is changes in driving. And then this is changes in walking. And these actually come from requests for Google and Apple Maps rather than any actual observation. So it's a really interesting case of using big data. The point that I thought was really interesting is that all 4 countries really had pronounced declines in all forms of activity. They're almost eerily similar. But what you might note is that only the US and the UK, especially the UK, really had these massive initial death spikes. And that, to me, indicates that there's not much relationship between the 2 variables. But the problem here, the reason I bring this up, is that because these are incidentally collected, they just show trip intentions, but they also might be non-representative in that only users who elected to turn on location history are showing up for the Google case. So this might be a non-representative selection of the population. And also people that have these phones, of course, many people in the United States have and use smartphones, and Google and Apple Maps are 2 of the most popular software applications, probably in world history, but not everyone actually uses them. So just worth noting here. Sometimes you have these problems of representation. And yeah, this is stuff that I kind of already said out loud before. Now, there is one thing I wanted to mention here, which is that if the people who turn on these services in country A are similar to people who turn on these services in country B, that means that even though they're both bad proxies of the population in a sense, they're both bad in the same way. And this is another way to kind of deal with that bias. So as long as we're comparing like with like, that's kind of the general principle here. It's not really a problem.
But the question again is, can we test that assumption? And the answer is no. Here's just 3 more countries that I think this is a lot more interesting last year when I first taught this course. But the issue is sort of faded now. But this is Colombia, Chile, and Peru. Their changes in mobility of different kinds plotted against their excess death. So lots of interesting, lack of a relationship really between excess death and changes in mobility, but just worth noting. Okay, so one more characteristic I want to mention. I keep saying one more, but obviously not the final one. There's 10. Is algorithmic confounding. This is basically what I was referring to earlier, but you could think about it as deserving its own slide. Remember that not only do social media firms not always really map real-world networks, but they also oftentimes try to actively create social networks. So if we think about looking at social media networks, these are not just existing networks. They're ones that social media firms also oftentimes are trying to stimulate. And so this kind of has the problem that it confounds relationships. So we're not just talking about offline social networks, we're also talking about the influence of these firms. The 9th characteristic of big data worth noting is that these data are, generally speaking, dirty data. Cleaning data is something that I happen to like. It's meditative. It lets you flex some genuine computer science skills that you might otherwise not use. But it can be very arduous, and mistakes are easy to make. Now, that said, people make mistakes with all kinds of data, so this isn't really unique to big data, but it's still worth noting. Here's an interesting study that we actually saw reported earlier. This is a really fascinating case, actually. So what's apparently happening here is that we saw this spike in angry words per text message around the time of the September 11th plane crash. So this is the estimated trends in anger over the course of the day. This is all just one day, by the way. And this is based on pagers. None of you probably know that much about pagers. I don't mean to be presumptuous, but why would you? But basically a pager was like a very primitive form of texting where you could usually just send pretty simple messages. So this looks like a really nice story here in the gray, right? We have this increase in anger as the day goes on. And you can see that there is still something of a pattern, but when we actually correct for this problem, that basically there was a single pager that repeatedly sent out this message, reboot NT machine, blah, 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 in cabinet, basically the word critical, and it sounds like the word critical is what triggered the pager to, or the algorithm to basically interpret the text message as angry. But without that, you can see that, the messages don't really display as marked of a trend. So this is worth taking pretty seriously. Finally, this is the actual 10th characteristic. Big data are sensitive. And this is kind of a fitting place to end because your final assignment is, of course, to complete your ethics certification. So here's a problem about big data that we've already mentioned, but worth saying a little bit more about. Remember when I said last week that it would be theoretically possible to identify someone's anonymous ID in the GSS or the CPS if you happen to know that they were sampled? Well, what if everyone is sampled? So what if you have these big data? Then there's this really severe problem that then you can just filter the data by characteristics you know to be true of the person. It's pretty straightforward. You can tell Stata to make a new data set of only the people that fit certain characteristics, and if you have a lot of information on them, you can really narrow it down quite a bit. Maybe even more impressively, these 2 researchers found that they could de-anonymize Netflix records fairly easily with just a couple of pieces of anonymized but relatively unique information, and it led to a lawsuit, actually, that I believe prevailed by a woman who felt outed by this. So basically, they were able to figure out, this is a little bit of a technical graph here, but they were able to figure out from people's approximate ratings of movies and the dates when they saw them, on a scale of like 3 out of 4 or 4 out of 5, that's the number of movies. So basically the graph is showing that if you could guess someone's rating of a particular movie on 3 out of 4 or 4 out of 5 movies, and you knew the rough date when they saw it, you could pretty easily, as long as you have some computer science skills, but any computer scientist in principle then, which, then someone just built an app and it gets out to the internet, you could figure out who certain anonymous reviewers were of Netflix. So this is a kind of important characteristic of big data, that they are subject to this problem. So thanks everyone for watching. I know this is kind of an odd place to stop in certain respects because we seem like we're just getting started on a really interesting and fun topic. I really encourage you to pursue this in the future if this stuff is of interest to you. Thanks for a great semester if you were watching this with me as part of SOC357, and if you just happened across this video on the internet. I hope it was interesting. Thanks for watching.